Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Mr. Ramesh Rao you, and he will speak on the topic post-harvest mechanization and automation in red chilies. I now request the speaker to begin. Thank you.
Thank you. Hi, this is Ramesh Rao, co-founder of Contrivation Labs. Uh, I I am basically an electrical engineer by profession, and I graduated from one of the premier institutes of India. I have been in the corporate world for over 30 years, and way back in 2019, I had this thought of developing something using my experience in multidisciplinary engineering companies for the Indian agriculture ecosystem. My observations come from my exercise routine where I used to bicycle around Bangalore. And I always used to see that the farmlands on the outskirts of Bangalore have very minimal automation or mechanization available. So that is how the idea germinated that we should do something which would help the Indian farmers, especially the marginal farmers. So with that in mind, Shruti and I started this startup in way back in 2019. We and our first product was based on our discussions with community farming communities in Andhra Pradesh, which is a large chili growing state. And one of the big challenges they face is post harvest, when the red chilies are plugged. They are plugged along with the stem and the calyx, which are adulterants to the color and pungency of the red chili. So the color and pungency are the key characteristics of red chilies. And there are multiple varieties of red chilies. So these stem and the calyx are separated currently. If you go to any areas where this process is done, it's largely manual, where typically women folks sit and separate them manually. There are some semi-automatic machines, but I'll come to that on a later stage. So the problem, what we wanted to address was that once the chilies are harvested and dried for a certain amount of time, uh, they need to be for especially for making organic dyes and export purposes, the stem and calyx need to be separated, which was a very manual process. And that's a big issue because there is a huge shortage of workforce, especially in the agriculture ecosystem. Also, these are prone. Stem is a piece of dead wood and is prone to fungal attacks. They need to be stored in a controlled environment, typically cold storages, which is a huge additional cost to the storage of the red chilies for a prolonged period of time. So, I kind of have put a few numbers here in my presentation. Basically, the cost of manual separation is around 25 rupees or upwards of it, especially in the season when the shortage is huge of the workforce. And with that in mind, we wanted to start an idea to how if we could automate this process of plucking the stem, how would it impact the whole ecosystem? So this is one picture which we have taken of how it is currently done. If you look here, you can see that there's a large amount of women folks sitting in a shed around chilies. So they are exposed to the chili fumes, which over a period of time is a health hazard. Especially they pick up respiratory disorders and all. And a rough estimate, as per the internet, is the cost of this is around 5,000 crore rupees per year, which is like the cost of treatment and indirect cost of lost productivity. That's a huge number we wanted to tackle. And then what we wanted to create was this a nearly touch-free operation. Basically, the idea was to pour the chilies at one side of a machine. And from the other side of the machine, we could get calyx and stem separated red chili pods. Um, we set with a target of processing 100 kgs per hour. We are slightly lower than that number, but over a period of time, as we introduce machine learning and AI into the system, we probably will reach it. Our goal was to reduce the cost of operations by approximately 30%. So, 30% of 25 rupees comes to around 20 rupees. So that was the target initially. We also wanted to create a system which works on single phase AC power, because if you go to the districts, there's a huge issue of power availability, and three-phase power is kind of difficult. So wanted to create a machine which would work on a single phase power, and it should be easy to use. Anyone with even a high school pass out should be able to operate this machine. That was the intent, and with that in mind, we went through the journey. So we started in our home garage, trying to build proof of concept to see whether we can actually do or create something like this, which would actually separate the pod. Some key issues which came, and some issues we wanted to tackle was that if you look at a red chili, it's a very light produce, less than a gram waste. So for it to move forward, or for us to do something with it, was a big challenge. So we started with conveyor belts, and we wanted to see if we can move them on a conveyor belt, and so on and so forth. So the first picture on the left was our first design concept, using conveyors to move the product, and then over using image processing and control algorithms to actually identify and find where the stem is, and separate the stem. The one on the right was version 2, or like a prototype which we built using conveyors and pneumatics. So we use pneumatic actuators instead of electrical actuators, which gives us efficiency benefit. And then this is how we envisioned our system. Basically, 3 meters by 3 meters footprint. But what we are currently been able to achieve is a 3 meters by around 2 meters, 2 meter system. So this is how the journey has been so far. And these are the key engineering steps which we do in a system. So this is a a kind of a pictorial description of how the machine works. So the three key steps is to move when we dump like a few kilos of chilies at one end of the machine. The first step is to move them in a single file, what we call a singularization of chilies. So we move them in a single file. The second is to use cameras and image sensing and algorithms, image processing algorithms, to orient the chili in the right direction. And then the third step is the key step, where we actually pluck the stem and the calyx from the red chili. So if you were to look at this picture, if you see at the singularization stage, the pod is in one case it is facing the image sensor, the other case it's not facing the image sensor. But once the process of orientation happens, the chili will always be red chili pod will always be in one direction, and the stem will always be in the front. That is how the actual process of separation happens. So if you were to look at the two blocks, blue blocks, those are pneumatic actuators, which come at the right point where the stem reaches there, and then plug the stem, which will be exactly like a human being will do. So we do not cut the stem, which would be like using a shear force, and which is what a lot of semi-automatic machines do. We plug the calyx and the stem from the pot, and then we also have another image sensor. When I say image sensor, it's a camera along with our proprietary and customized image processing algorithms, which will do the quality check, whether the stem is still there. If it is there, we will reject it. If it is not there, we'll throw it out of the machine. So that is basically the fundamental approach which we started designing with, and that is what we are doing today. Um, And some bit on the technology. Technology is like we use edge computing. We're using low cost image processing units, so low cost cameras, our own algorithms. And we use control algorithms to manipulate the actuators and how we move the chili into the system. And as we were developing this whole thing, we also realized that we are kind of creating not just a specific solution for a specific problem, but rather we realized as we were building this over the last few years that we actually have a technology platform which we can translate to other producers, root vegetables like carrots when they are plucked from the when they are kind of pulled out of the ground. They're pulled along with the leaves, and we can use this whole platform with changes in the mechanical system design to kind of remove the leaves from the carrots also. So what we have realized is as we start commercializing the chili plucking solution, we can also move forward in our in our journey to create solutions for, like, root vegetables, or for sorting and grading of fruits like mangoes and apples and things like that. Not just a specific solution to a specific problem, but as we over a period of time formulated and conceptualized the solution, we also realize that we have a technology platform which we can quickly move on to develop next products of our company. A bit on red chilies. Why we, as I mentioned, that we had taken this as our first problem because that is where most of our uh, of our discussion with customers happened, for farmers who have been cultivating chilies for ages. So. But then it's not just someone tells you to solve this, and you have to look at the market. You need to understand whether the solution we are building is for a suitable market or not. So, red chilies. India is the largest producer of red chilies. We produce about one third of the global production. So. We have been consistently year on year averaging around 2 billion tons, around 2 to 2.4 million tons, which is about one third of global production, which is 6 million, like a straight cut. And another interesting observation we had as we were looking at the market, we were doing our market research, and things like how much should would we be able to capture this market for processing of the red chilies. We realized that a significant portion, like 75%, around 75% of the chilies are grown in Andhra Pradesh, Telangana, and Karnataka, which are three adjacent states. Which actually, from a management perspective, was a very positive for us, because as we when we go next in the next 3 4 months, we are going to start deploying our machines in the field. We would we easily be able to consistently provide management bandwidth to the engineers who would be stationed at the field. So that was a very positive. And was a good I mean, if you look at hindsight, it was a good idea to enter into chilies with minimal management bandwidth. We do not have to build large teams around it. And then other state which grows significantly is Madhya Pradesh, which is also not very far from Karnataka. We are based out of Bangalore, so which are not very far. So we thought we had the right engineering solution, we had the right market, and based on that, we also calculated, what would be like, how would the market look like, a TAM of 7,500 crores globally. And if I was to just look at India itself, and this I'm talking like annual processing costs, 25 rupees per kg. For India only itself would be like 2,600 crores. And if I was to just look at the three states, which is 75% of that, 1,800 crores. So the market size from an opportunity perspective looked very good. And we are our initial plan is to target around just about 25 to 30% of the market, which will give us a good runway to move into large scale production, and also keep our R&D working on other product solutions. So that's the plan in a nutshell. And this is how we wanted to go to the market. So this is very important. Every time, and I'm talking from this from age and my experience in the corporate world, you need to have a very robust, go-to-market strategy. As robust as your technology roadmap is, it's your go-to-market should be equally robust. So, with that in mind, what we said was that as year progresses, initial years, we will sell our machine as a machine solution. So we will sell it as a machine to large businesses. So typically, what is called as B2B sales, and as we progress on to year two and beyond, we will start developing partnerships with typically with agri-tech platforms. There are many agri-tech platforms which are consolidating in the districts, and they work very closely with the FPOs and the farmers. So idea was to work with them, and progress. Our next step or our next revenue stream would come from machine as a service, where either ourselves or through our franchisee networks or some manner, we do not sell the machine to the customer, but we kind of provide the service of the machine. So this would help like directly the farmers and FPOs, where they can come process their produce. So let's assume a farmer has in a specific season has produced like 5 tons of red chilies. So they can come and process the 5 tons, and then pay us for the amount of chilies like by. So if we, let's say we are saying 20 rupees per kg, or 18 rupees per kg, just pay us for that amount. So they don't have to kind of burden themselves with the ownership of the machine. Because this machine 5 ton would happen in like just maybe 10 days, and then it will remain idle with them. So the idea was to do not give them do not like kind of burden them with the ownership costs, but to get them the benefit of the machine or the solution which we are building. And then, year five or beyond that, we would want to go and look at international markets. The idea of keeping this, way back, or 3, 4 years down the line on our roadmap was that, especially when you're installing your machines in international markets, the cost of any maintenance or repairs is very high. We will either have to station an engineer outside the country, or you have to send them every time there's a problem. So the idea was to kind of in the initial 3 to 4 years, when we have installed these machines and commissioned them in India, and they have been working, we would have also got feedback on potential problems, and things which are happening to the machine which need services, and then plan our strategies, either by redesigning the product or reducing those kind of or defaults or faults in the machine. So that's the reason we said we'll move a few years down the line, we'll go into the international market. But then that's the kind of go to market strategy we have in place. I also named some of the customers. The ones in green are very active. We are very kind of positively working with them, and somewhere we have initiated the discussions, and then we do have a large pipeline of these are typically exporters, large aggregators in the ecosystem, who we are looking at as a potential customers over the initial years of the business. Some customer benefits, I had been mentioning reduced operational cost as compared to the manual workforce. Our return on investment is pretty much like less than around 2 years, let's say, when you're doing a 365-day operation. And dependency of low labor significantly reduces, because to operate these machines, you do not need large workforces. Just two, three people just to load the machine with the chilies, are enough. Or if you kind of create an automatic loading system, where the truck dumps dumps in one location, and from there, you can automatically load. Then it's still less. So huge, huge positive for us, especially because labor itself is in India is very, very, difficult to get, and always in shortage, especially in the season. Uh, Approximately, based on what our calculations and how our efficiencies and effectiveness of the machine is, that one system or one cal extract, which is what is the we have coined that the machine name as cal extract, would be equivalent to, like, 35 to 40 people. Increase shelf life as you separate the stem and calyx from the pod. It is easier to store. You can vacuum pack these machines, and once you vacuum pack these red chilies, then there is, like, you don't need cold storages. You can just keep them in room temperature, and they will stay pretty much healthy. So cost of storage reduces. Then shelf life increases. So that those are significant positives, or the customer benefits. This is a rough estimate of how we want to grow. As I mentioned, we want to kind of start slow and then exponentially grow 3 years down the line. And then our idea is to have at least 2,000 machines by 8 years. So like 2034-ish, we want to be like having an install base of 2,000 machines across the globe. And then you know, uh, and kind of have good revenues. That's the plan for CalExtract as we speak. And so as you do like technology development, you have your go-to market strategies and things in place. You also need to have a strategy, especially when you are building a product, which is like a physical product. You also need to have a manufacturing strategy of, how do you want to build and plan. So our strategy as a company, what we think is that we will outsource our manufacturing through our manufacturing partners. So the idea is to hand over the the build process, supply chain and build process, to experts in the field, who have been building machines, as their core business. So, and then we also said that we'll have a two-pronged strategy on how we develop our partner. One would be for like the initial development phase, steady growth, few medium scaling up, and then we should also have a rapid scale up, like a large organization who does nothing but just build the machines day in day out. So that was the strategy, to have one to just rapidly explore our manufacturing capabilities, and one who would work with us through the initial phases, where we are developing phase, and then establish the supply chain, and they work with us. So that's the plan of how we want to work on the manufacturing front. Uh, it's a very conscious decision of, though we have worked in manufacturing, we have worked in product companies, all three founders. It was a very conscious decision that, we will not, build our own manufacturing facility. And then, we will focus purely on our design and, how do we go to market and things like that. So that was the manufacturing strategy part. And as any startup, the biggest challenge is you start with your initial bootstrap, and then you start looking for fronts. And my suggestion, from my by starting this particular venture, is that you should focus a lot on government schemes and academic institutions and research institutions who provide a lot of support, especially when you're doing like this deep technology research, or into AI, machine learning, robotics. So there are a lot of them. So we do have a lot of support from research organizations like ICAR, which is like the agriculture research part of Indian government. So we have got funds from them. We also have got funds from the Department of Biotechnology. We have got funds from Indian Institute of Science, which is like one of the best engineering and science institute in India. We have also got some from management institutions like IIM Lucknow. Then CCAP is a large incubator based out of accelerator incubator based out of Bangalore, who we work with very closely. So those are our kind of our partners, or those are the people who have kind of believed in our product, believed in our thought process, and they have kind of put funds either as grants or equity. So there are some who have put it as equity, some who have put it as grants, who have given us money to research, do our research and development work. So we do also have trademarks for Calextract, and we also have filed a patent, so that we protect our intellectual property, which is a very key factor, especially when you're designing very high-tech products, like technology-based products. So we do have applied for a patent. It's a process which takes some time, but hopefully we should have one in our bag soon. This is a bit on the founders. I've spoken. I come from an electrical background. Shruti was Shruti and I have known each other from 1995. We married in 1996. Shruti had taken a long sabbatical. She came back with this venture when our kids had moved to college, so that both of us were ready to follow this passion of ours. So. She's also very passionate about working with the farmers and helping. So she had been doing social work, and then she moved to this, where we work closely with the farmers. Vijay Iyer is the third co-founder. He is We have known Vijay from 2000 onwards. So all of us have known each other over 25 years. And Vijay comes from a supply chain operations background. So companies we have worked, Samsung, IBM, General Electric, so mostly engineering companies, who have kind of been renowned in the world for their engineering capabilities. So that was what we wanted to leverage and build this product. So um, that's a bit on the co-founders. Of course, we have a team of engineers who work with us, build the product. So pretty much a rounded up team. That's my last slide. I would open for questions now.
Okay. Thank you very much, sir, for a wonderful presentation. I'll take up the questions now. In the
Yeah,
meantime, can you please stop sharing the screen, sir, so that we can see your full video?
sure. 1 minute. Stop share. All right.
Okay. I'll move on to the questions, sir. The
Yeah.
first question is, what is the typical processing charge for per kilogram of red chilies, and what services are included in that cost?
Okay. So today, if you were to look at the market, it is done manually, and I told you it is upwards of 25 rupees per kg of red chilies. We do the exact same service. You get your chilies along with you to this machine, and then you feed the machine with these red chilies, and the output would be a separated red chili pod. So it will do exactly what we have replicated the whole process, what human beings are doing today, to what the machine would do. It will just separate, and the cost of separation would be anywhere between 17 rupees to 20 rupees.
Okay. Is there a minimum quantity of red chilies required for processing?
No, you can process. So the way it is you can process any quantities. You can start with like 1 kg. But the problem is that this is about machine utilization, right? So if I can process, let's assume 50 kgs, the machine can process 50 kgs per hour. And if you are giving, let's say you just want to process 50 kgs today, so that whole process will have complete in 1 hour, and the rest of the day the machine is going to remain idle, which is like miss. So the idea is to keep the machine up and running as much as possible, like typically 24 hours a day, so that you get the best out of the machine. So there is no machine requirement, or there is no system requirement of a minimum quantity, but To run it efficiently and effectively, our recommendation is to can be continuously feeding the machine through the day, so you get the maximum output out of the machine.
Okay. How do you ensure consistent quality and minimize losses while processing large quantities of red chilies?
Done. So we are, as I mentioned, we pluck one stem at a time. We are not like collecting. So that in itself, because we are only processing one chili at a time, and let's say the machine will process, let's uh, say 20 chilies per second. But all these 20 chilies are processed separately as single chili. So that improves the effectiveness or the quality. Second is obviously it's a machine. There will be defect generation. So currently, what we are seeing is a output of 90% plus. So which means for every 100 chilies processed, 90 chilies are good 100%. So that 90% can go up to 94, 93, and 6 chilies will be bad. So that is what we are achieving today. And as we build our machine learning model around this, I'm sure you all have heard about AI and machine learning, which is like the key buzzwords in the society today. For agriculture, building a machine AI model is always a challenge because there is no data around, data set which is required to for the machine to start learning and recognizing defects. But we are building the data for chili specifically for our problem, and then once that data set is available, once that happens, once we start processing large chilies, uh, we will be able to improve the effectiveness of the machine to upwards of 96%. So that is the benefit we get. So if that answers your question.
Yes. What are the common mistakes farmers make during post-harvest handling that reduce market value?
So I'll take one step backward and explain how the whole ecosystem works. So farmers, if you look at typical Indian farmers, average the land holding is not very large. India's average farmer land holding is less than 3 acres. So uh, the amount of chili an average farmer, marginal farmer produces is not very it's a few like less than a ton actually. So what they do is they sell it to aggregators. Aggregators are people who sit in, the mandis or the APMCs and buy chilies from the farmers. So the mis and then from there a larger aggregator collects bigger volume, and then this whole process of separation happens. What mistakes a farmer generally makes is that they don't utilize the governmental processes very well. They will sell the chilies to the same aggregator they have been selling for generations. So that is one. And of course, sometimes because they if they hold the chilies for a larger period of time, it's a commodity. The prices can change. So those are typical. But otherwise, once the farmer produces the red chilies, they kind of hand it over to the next stage of aggregators as quickly as possible. Uh, and another problem, which I mean, this is not just chili problem with the chili farmers, but I see is that you know. I'll give you an example of Karnataka. Bayadgi is a place in Karnataka which is famous for the Bayadgi variety of chilies. Uh, but the fact is that within 100 kilometers radius of Bayadgi town, there is no Bayadgi chili grown. It's grown outside of that town because the soil, farmers don't maintain their soil. The yield of the soil starts deteriorating. So that's a problem across. So I wouldn't say very specifically to this particular red chilies, but farmers need to kind of uh, not just worry about the yield of the or the produce per season, but they should also look at how well the farm is maintained. There are a lot of startups who are working with them, like they do satellite imaging and all. So hopefully that problem will go away, or at least be answered, is what I think.
Okay. Do you offer equipment only for red chilies or also for other crops and spices?
So today, our product, the first design which we have done is only for red chilies. Cal extract is only meant for red chilies. But as we start commercializing this product in the next 3, 4 months, our design team will move on to building other produce, like as I had mentioned, for root vegetables and fruit, grading and sorting of fruits.
Okay. What has been the response from farmers and FPOs to your equipment, sir?
We have seen from every possible touch point we have made in this ecosystem. The feedback is very positive that this is one large gap in the overall system which needs to be automated. Because if you look at other processes like converting red chili into powder or paste or chili flakes or organic dyes, all of them is a fairly automated process. Like large machines are there to pounding and things like that. This is one kind of a huge gap which we are filling. We have heard this from farmers, FPOs, spice processing units, academic academic institutions, and like agriculture universities, research people like ICAR research facilities. Everyone has said this is one large gap which needs to be fulfilled, and hopefully we will be the first ones to do that.
Okay. Are there any government schemes or partnerships that support farmers in accessing mechanized post-harvest equipment?
So I may not have the right answer to that. I may not be the right person, but I do understand that especially FPOs, once the farmers form the community, like the FPO, the cooperative, the banks do and the governments does help them with subsidized purchasing of the equipment and things like that. But I may not be the right person to make the comment. But I do know that FPOs and especially the FPOs, they get subsidy benefits from the large banks and NABARDs of the world. So, but again, may not there may be much more support from being provided by the government. I won't be able to make a comment on that.
Okay. Sir, who are your primary customers? Individual farmers, FPOs, traders, processor, or exporters?
So our key customers would be aggregators who are the traders. One, second would be FPOs. Two, and third would be spice processing houses and exporters. So spice processing house, like people who sell red chili powder. They may, when they buy chilies from the traders, if they buy without the stem, they can put our machine and do it. But otherwise, exporters need it for sure, because for you to export red chilies, you have to separate the stem and the calyx from the pot. So exporters, large traders, and FPOs are our customers.
Okay. In which states are your services currently available, and are there plans to expand across India?
Okay, currently we haven't commercialized our product. As I mentioned, we will be in the next 3, 4 months. Our final testing is progressing as we speak. So our initial focus would be in Karnataka and Andhra Pradesh and Telangana. Those are the three areas where we want to focus. Post that, we will go to Madhya Pradesh, maybe next year or 12 months down the line. We'll go to Madhya Pradesh. Inside of Karnataka, we will focus in Gadak, Bagalkot area, around Bagalkot and Bellary. In Andhra Pradesh, we'll be mostly around Guntur. And in Telangana, we will focus around Warangal and Khammam. So those are our focus areas in the initial phases.
Okay. What advice would you give to young entrepreneurs who wanted to build technology-driven business in agriculture?
Uh, Interesting. So my advice is that even before you start, you should understand, one, what is the technology you want to build. Two, what is the market you want to address. So those are very key things which you need to start with, because if you build a technology which does not have a market, it is of no use. So think of the technology and think of a market. And market may not be available today, but then it may be available in the future, near future. So even that for me is an available market. So you can have some forward-looking technology which comes, which you're ready to build and may not be used today, but it can be used in like a few years down the line. Then work on it, and second is be passionate. It's a long and journey. It's not that success will come very very quickly. So there will be your good days where everything goes good. There will be those bad days where you will struggle, but then be passionate about what you're trying to solve. That is what is very key. And third is initially look at various if you're especially if you're in India, look at various government support which is available either directly from the government or through academic institutions or research institutions, because that's a huge support both from a funding perspective as well as from a knowledge perspective. So that is what you should look at.
Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we would like to thank Mr. Ramesh Rao for the talk and for answering the questions. This meeting will now be closed.
Thank you so much. I appreciate your time and giving me this opportunity.
Most welcome, sir. Bye bye.